Hi all, very good evening. Hi Kriti, hi Shiva. Did we do the lab for the AMI creation yesterday? Kirti, Shiva? Okay, so in the part of today's lab, we are going to learn about what is EFS, that is Elastic File System. So there are various advantages that we get with the help of Elastic File System, and let's get deep dive into it. Now, when I go down to my AWS console here, if I click on services, you'll be able to see the EFS as a part of different storage service itself. Right, it's not under the EC2, but it's a part of different storage service itself. So I'll go ahead and click on EFS. So there you go. We have been able to open up the EFS file system dashboard page. If I click on this region here, you see that EFS is specifically available in few regions at this moment of time. They're still developing this kind of system to be available in all the different regions. But currently, if we want to use, we may have to go to North Virginia, Ohio, Oregon, Sydney, or Frankfurt, or Ireland. So we are using the North Virginia region in order to do this specific lab. So if I go scroll down, the first important thing that we see here is now with the EFS file system, I don't have to mention the storage itself. So what is first EFS? As we know the name Elastic File System, and the name says the first one, Elastic. What does the Elastic mean here? Which means it can grow and shrink on its own. It means I don't have to specify any size for this file system at all. Like let's say when I'm going to spin up an EBS volume, I need to say that I require a volume of 8 GB or 10 GB or 100 GB as such. But when it comes with the EFS, I do not have to mention anything as such, right? So I can start with 0 bytes, and whenever I'm going to go ahead and store the data, automatically the size is going to increase. And if I'm going to remove the data, automatically it's going to be decreased overall, right? So this is the beauty of this elastic file system, that it grows and shrinks on its own, and I'm going to pay only for what I'm going to use. So even I don't have to pay for any charges, for which in the EBS, if I say I want to use 8 GB of volume, I do have to pay the charges whether I use it fully or not. But in case of EFS file systems, I'm going to pay only for the amount of storage that we are going to use across. And the next important thing, what my EFS is going to provide is, it can help me connect with not one, not two, not three, but tens, thousands, and hundreds of EC2 instances can be connected to the same file system at the same point of time. Like if you think about connecting one EBS volume with two different live EC2 instances, is it possible? No. It is like I have one hard disk and I'm trying to attach it to two computers at the same time. Yes, we can use the data to be stored on EFS. So there are these are all the important features that we actually get. Now, as we were talking about EBS volume. Now let's say if I want to share this EBS volume with two different EC2 instances at the same time, I'll not be able to do it, right? So it is just like I'm having one single hard disk trying to connect to two different computers at the same time, which is not a possible methodology. But if I want to do something like that, we have EFS, where it's not one or two, but I can connect tens, hundreds, and thousands of EC2 instances to the same file system at the same time. So let's see how we can actually do it. So I'll quickly go ahead and click on create file system. It's very easy to set up. So the first step is basically it is going to ask me which VPC would you like to put this file system into. So currently we are going to make use of the default VPC itself. And we are, as we all know, North Virginia has got 6 availability zones. There is 1A, 1B, 1C, 1D, 1E, and 1F. So 6 availability zones, and each availability zone has got one subnet as a part of this default VPC. So all of them are automatically listed here. IP address, I'll just keep it as automatic. And then the security groups. So the default security group is already included. I'll quickly go ahead and add one more security group, that is web server. So I'll quickly add the web server security group across all of the availability zones. Okay, so this is the step one, where we had to just select the VPC and we had to ensure the mount targets are created. So for the mount targets, I need to ensure that I select all the availability zones, all the subnets are automatically coming up here, and then IP address is going to be automatic. And the security groups, we have selected the default and web server to be the part of each availability zone. I'll quickly go ahead and say next. So the next step is just going to ask me for the tags. So I'll just go ahead and say my first EFS, and then it's going to ask me for the performance mode. Now, as I said, it is actually helping me to connect not one, not two, but tens, hundreds, and thousands of EC2 instances, right? So if you have around tens and hundreds of instances, go for max input output, so that it will automatically be able to set itself for the input output per second transactions happening, right? So IOPS will be automatically adjusted if I am going to connect it to hundreds and thousands of EC2 instances, but I need to select this max input output performance. If I'm just using for testing purpose for one or two EC2 instances, then just go for the general purpose. Then we have the enable encryption. So for now, I'm not going to enable encryption. I'll just leave it as default. So if you want to enable the encryption, just go ahead and click on this enable. It is going to ask you for a KMS key, and then with the help of that KMS key, I'll be able to encrypt the drive. I'll quickly go ahead and just click on next step. So there we go. So what did we do in this specific place of creating a EFS? So we just did two steps. The step one was about selecting the VPC and then selecting all the availability zones and included all the security groups. And the step two, what did we do? We specifically gave the tag with the name my first EFS, and the performance mode is basically default for us now. And there is no encryption at this point of time. And I'll just go ahead and click on say create file system. So this EFS file system is going to take a little while for us to get it created. So we'll have to wait until this EFS is going to come up. So remember, what are the major important things that we can do with the EFS? EFS stands for Elastic File System. As the name itself suggests, it is elastic in nature, which means the size of the EFS grows automatically, shrinks automatically. I can start with minimum of 6 bytes. You see here 6 KB it is showing, right? So it has started with 6 KB, and as and when I'm going to add the data, automatically it is going to grow across, and as and when I'm going to remove, it's automatically going to be shrinking across. So I am going to pay only for the charges that I'm basically using it for. And in terms of other important advantage, with the help of EFS, I'll be able to help not one, not two, but hundreds of EC2 instances connected to the same file system. So as we all know, one EBS volume or one hard disk cannot be connected to two different computers or two different servers at the same time. So in order to achieve that, we specifically use the EFS. While the EFS system is being launched, let's quickly go down to the EC2 services and launch the EC2 instance, which is going to get connected to this EFS. So I'm going to launch two different EC2 instances. I'm going to select Amazon Linux AMI. And next T2 micro. I'll leave everything else default here. I'll quickly go and add storage. So I'll have a root volume still with 8 GB of size because I need operating system from where my EC2 is going to operate. I'll go ahead and add the tag. I'll just give the name as EFS Lab 1 Instance 1. I'll put it behind the security group, that is SSH, as well as the web server. And then quickly go ahead and launch using one of the key pair that we already have across in our systems. Similarly, what I'm going to do is I'm going to quickly go ahead and launch the instance in one of the other availability zone. So we have launched one EC2 instance. Similarly, I'm going to launch one more EC2 instance. The first one is actually launched in US East 1B. So I'm going to make this launched in some other availability zone apart from the US East 1B. So I'll select the T2 micro here. So yeah, I'll just select that any of the availability zone apart from 1B. I'll just put it across in, sorry, 1E. And then let's quickly go ahead and say add storage, 8 GB of size for the root volume, and then adding the tags. I'll name it as instance 2. I'll put across a security group. I'll use the SSH and the web server security group. I'll quickly go ahead and quick launch. So I'm going to use Virginia Keeper again to get it launched, and then click on launch instances. So there we go. We have successfully launched both the EC2 instances in 2 different availability zones, and our EFS file system is also already under creation. So let's see if the EFS has been done. I'll just go ahead and click on refresh. I'll scroll down the page. Yes, it says it is available. Now I should be able to use my EFS file system. Okay, now first thing is I'm going to go ahead and quickly go into the each of these EC2 instances. So let's open the PuTTY terminal where we are going to make the configuration settings on how this EC2 instance is going to get connected to the EFS file system. So the first one is here, the server one. I'll go ahead and put across SSH, auth, and then Virginia key pair. So I'm opening the instance one in the black colored window. Now let's open the instance 2. I'm going to open up this one as well. So this one I'll open it up in a different color. So I can just go down to the colors, click on the default background and put it as a green color. So before I open, I'll just check out that the first one has not connected. Again, it is due to the security groups. So I'll just go down to the security group here. I'll have to change my IP address again in the SSH security group. Let's open a green server box. And in the meantime, I'll just go ahead and say restart the session for this. So it's going to ask you to verify the key fingerprint. I'll say yes. Then you'll go ahead and say EC2-user. So we have been able to log into the first server. Second server is also asking me to verify key fingerprint. I'll just say EC2-user. So there we go. We have got 2 EC2 instances with the 2 different color boxes, and now we are going to go ahead and get connected to the EFS file system. So remember, what is EFS file system? It is a place which is going to help me connect the different EC2 instances to the same file system. It is like connecting one EBS volume with the 2 different EC2 instances, which is actually not possible. Like one hard disk cannot be connected to the 2 different computers at the same time. So how can we resolve this situation? So Amazon has created something called as EFS, which is called as Elastic File System, which is actually going to help me across to establish this connection of same file system with the multiple EC2 instances at the same time using the EFS. So let's go down to EFS now. So in the EFS, I specifically see that I have some mount instructions here. So these are the mount instructions that I specifically need to follow. It's very simple. Just come down to the page where you have created a file system and you'll be able to see Amazon EC2 mount instructions. Just click on that. Now the first thing is I need to install the NFS client here. So since we are using Amazon Linux AMI, so I'm just going to pick up this specific command, sudo yum install -y. It says the package is already installed and there is nothing to do yet on this specific black colored machine. Let's do it on the green one as well. So it also says the same, the package is already installed. It has got nothing to do with it at this point of time. That's great. So we already have this utilities. Now the next step is mounting the file system. So I just need to go ahead and create some directory where I'm going to mount this specific EFS volume. So what I'm going to do is, let's go ahead and create some mount point. So I'll just go ahead and say mkdir. I'll just say here Pawan. And now let's try to create some other box in this. I'll just say mkdir and then I'll try to create Kumar. Okay, so we have created two different directories in two different places. Now I'll need to use this specific line, completely copy until here and just leave off this EFS because we have created with the name either Pawan or the Kumar, right? So we are going to use those. So you don't have to remember any of these mount instructions, as we all know how the mount instructions work. So it is mount -t is basically the type. Here we are using NFS4, and then there are some parameters that they have been set up here, and this is the place from where the IP address of this specific file system starts. Right, so I'll just go ahead and copy this everything. I'll put as Kumar here. Okay, so this is not going through further, so we'll have to check through why. So I'll just go ahead and say Control C. I'll just check the security groups that we have attached for the EFS file system. It was basically the default security group and the web server security group, right? Let's check out with the EC2 instances. So my EC2 instances have got only web server SSH and the are the only two security groups. So I actually need to attach it to one more security group, that is default security group. And now why default security group, I'll tell you in a little while. When I go to networking, click on change security groups. I'm going to set this default security group as well. So I'll update it for both of them. There you go, we have attached it. Now if you actually check what is available in the default security group, I'll click on view inbound rules here. If you remember, in the default security group, we have actually all ports, all protocols enabled, but it is opened up only for this same security group itself, right? So I want to ensure that the both EC2 instances can talk to each other with the help of EFS file system. So now if I go back and run this command again, There we go. It is now mounted up. I'll open up the black box server. Here I'll just go ahead and say Pawan. There we go. We were successfully able to mount it. Now let's go ahead and inside this specific directory. I'll go inside the Pawan here, and I'll go inside the Kumar here. Now, if I say ls, there's nothing inside this at this point of time. There's nothing here as well. Right? Let's go ahead and create some files here. I'll just say training.txt file. This is a training file. So I'll go ahead and save this. Okay, it is not allowing me to save it because we have not elevated our privileges to the root user. So I'll just say Control X and I'll first elevate my privileges and again try to create the file. Okay, so I have went and saved it. If I say ls, you will be able to see that there is one file with the name training.txt which has been created. Now, if I go back to the green box server and if I just say ls, you will be able to see that the training.txt file is available. So EFS file system is really working cool here. Like I don't have to yeah. So what happens is whenever we are launching a EFS file system, we have attached a couple of security groups here, right? So the two security groups that are attached to each of the availability zone in this EFS is web server and the default. And as we all know in here, the default security has got one capability that is about in the inbound, all ports, all traffic, all protocols are allowed only for the same source, which means if I have two EC2 instances connected at the same time, both of them will be able to talk to each other, right? So in that way, I am basically using this EFS file system get integrated with all the virtual machines together. So now if I go ahead and create something in this green color box, let's say I want to create one more file with the name index.html. This is a index file. I'll even write created from green server box. This is just a testing file, so I'm writing something here. Okay, I'll have to elevate my privileges. There we go. If I say ls, I have two files here. One is with the name index.html, other is the name training.txt. If I go back to the black server box and check out the same thing, if I say ls, you'll be able to see that the file with the name training.txt and the index.html are appearing. Now, if you want to see the contents of the index.html, let's go ahead and say cat index.html and enter. So it says this is a file created from the green server box. This is the one line of content which is available inside this index.html folder, right? So this is how we'll be able to specifically use the EFS file system. So EFS file system is very easy to set up. Just go ahead and click on create EFS file system, and as you all know, it is available in only certain regions at this point of time. All you need to do is select a region where we can set up the EFS. So in our case, we have used North Virginia region to set up the EFS file system. And once you go ahead and start creating the file system, first thing it is going to ask you is for the VPC. And in the VPC, it is going to select out all the availability zones. And you need to specifically mention the security groups which are going to be a part of this EFS file system. And in the second step, we have just added what is going to be the tags here. So we have added the tags, and then we have also selected the kind of performance. Since we are using only two EC2 instances, I have selected the general purpose. So if it is more than 5 or 10, then you can use the max input output performance mode. So that is it. That makes EFS file system setup. No, there is no limit of the usage. It all depends upon the amount of storage that you are going to put across in this file system, and automatically the size of the file is going to grow, and we are going to pay only for the amount of storage I am trying to do across. So any questions or doubts before we move to the next part from the EFS? How about you, Divya and Rahul? How about you, Rahul? Were you able to follow through? Okay, sure. So specifically, just important points to remember for them from the EFS. So one is the size of the file system grows automatically whenever I'm going to add the files. So I can start with the minimum of 6 KB as you see here. So it starts with the 6 KB and automatically it can grow up to any size that you want to grow with. And second important feature of EFS is I'll be able to share not one, not two, but hundreds and thousands of EC2 instances connected to the same file system. So I'll quickly go ahead and delete this before we proceed for the next part of our lab. So this is going to take a little while for the EFS to get deleted. That's fine. So we'll go back to our EC2 section, and the next part of the topic that we are going to look is really the important one. That is about the load balancer. Now, until now, we have covered all the different parts of the EC2, where we learned what is the EC2. It is Elastic Cloud Compute. How can we learn to launch our own virtual machine, whether it's a Linux or whether it's a Windows. Then we learned in detail about what are the security groups. Then we learned about what is Bootstrap. We learned how to create AMI. We learned in detail about what are the volumes and the snapshots. We learned about the instance metadata, placement groups, how can we use the IAM users and the roles with the EC2 instances, and which among the both is a secure way to connect with the S3 buckets. And then we learned about command line interface, on where we executed some commands to test out and establish a connection between the EC2 instance and S3 bucket. And we were also able to look through what is EBS for the instance store volumes and the RAID volumes as well. So just now we just completed one other part, that is EFS, and the next important part that we are going to learn is about load balancer. So before that, okay, how much are they going to charge for the EFS? Okay, even I'm not sure about it. Maybe we can just go to a calculator. and just check it out. No, it's not mentioned on this calculator here. You pay per GB for the data occupied to the Amazon EFS. It is around like this. For every 1 GB, you are going to pay $0.30 per month. So with first 12 months, you get up to 5 GB per month of the free. So you can go ahead and use up to 5 GB for free on the complete file system for 1 year altogether. So here they have also shown one pricing example where one of the person has actually used the file system in the US East North Virginia region with 100 GB storage for the first 15 days and 250 GB storage of the last 16 days in the month of March. How is the calculation going to be in this specific case? So the total usage is basically the number of GB per hours. So the first 100 GB is used for 15 days and 24 days per month, plus next other one is used as 250 GB for 16 days and 24 days per month. So it's going to be 132,000 hours GBRs. So if I'm going to get converted it to the calculator basis of 0.30 GB per month, so it is going to be 177 in GB into 0.30, it which becomes $53. So it's basically $0.30 per month. So it's fine for the now in order to test it across. Anyway, as a part of free tier, we are going to get 5 GB free for entire 1 year. So you can play around with it. Okay. Now discussing about the topic which is called as load balancer. Now, as the name itself says, it is going to balance the load. But where is it going to balance the load for? Now, when we think about the real-time websites like Gmail or Facebook or Amazon or Flipkart, have you ever seen any downtime for these websites? It's rare, right? Most of the times they are available, and it does happen that sometimes there is a huge problem and when it went down, but 99.99% of the times it doesn't go down, and it is available for the end users 24/7, 365 days. So how are they basically going to maintain these servers to be available 24/7, and how are they able to cater the requirements of all the users? That is because they have got something like load balancer, which is actually balancing the load. Now whenever we are going to set up a web server in the real time, it's not going to be one single EC2 instance. It is going to be basically multiple EC2 instances in front of which I'll have a load balancer. So the load balancer is going to decide where the traffic is going to be diverted. So it's automatically going to divert it across multiple EC2 instances so that the load is shared. So it will be something like this. Let's say I have got flipkart.com, and then this flipkart.com is basically connected, is actually hosted on two servers. Let's say the server one is EC2 1. This is one EC2 instance, and there is one other EC2 instance, right? So actually it is being hosted across in two different EC2 instances, but on top of it basically I have got something called as So the load balancer is the one on top of these two EC2 instances, which is going to manage how much amount of load should be going to each of these EC2 instances, and it is going to ensure that the health of my instance is working fine. So it is going to keep a check of health, whether the EC2 instance is working fine or not. So this is how in the real time the things are actually set up with the load balancer. So I have a load balancer across all the real-time web servers, which helps me to ensure that my web servers do not go down even for a single point of time. So let's learn how to set up a load balancer. So I'll quickly go navigate back to my AWS console. I'll close this. I'll go down to this specific section of the load balancer here. Click on the load balancers. So there we go. I get an option to create load balancer. So if I go ahead and click on create load balancer, it's going to ask me what kind of load balancer would you like to create, whether it's an application load balancer, whether it's a network load balancer, or whether it's a classic load balancer. So first we'll learn how to create a classic load balancer. I'll click on create. So I'm going to name it as my classic LB. LB stands for the load balancer. And currently we have this VPC, which is by default available in North Virginia region. I'm going to make use of the same default VPC. And then the third step, it is asking me whether it's going to be an internal load balancer. No, this is not going to be internal load balancer, because this is going to be a public URL exposed to each and every user. So anyone in this world should be able to access it, right? So I'm going to uncheck this option, that is create internal load balancer. Then it gives me option enable advanced VPC configuration. So for now I'll just leave it as default. I will just go with the normal default configuration itself. And the next is listener configuration. So the listener basically is going to give me on what protocol the load balancer is going to operate and on what protocol instance is going to operate. Now, as we all know, for from the internet, if I have to connect to an EC2 instance, which is actually like a web server, what do I need to do? We need to open up the port 80 and the port 443. Similarly, now if the load balancer is going to be the face of my web servers, I'll have to open the ports for the load balancer at this point of time. Right? So I have to open up the ports for the load balancer as well. I also need to map this load balancer with the EC2 instance. Right? So I'm going to open up the port 80 on the load balancer and the port 80 on the instance as well, right? So I'm going to map with the port 80 of the load balancer with the port 80 of the EC2 instance. And then I'll go ahead and click on next assign security groups. So I'm going to open up the web server security group here, because this has got HTTP and HTTPS protocols opened up, and specifically with the load balancer, I just want only those ports, that is 80 and 443, to be opened up so that my end users will be able to connect to the load balancer. And then the load balancer is basically mapped to the EC2 instance with the help of port number 80. That's fine, and let's go ahead and configure the security settings. Since we are using HTTP protocol, currently we do not have any secure listener. So if we actually go back to the step 1 and start using the HTTPS connections, which works on 443, you will have to basically go ahead and configure the SSL certificate. So we'll do that in the upcoming labs. For now, I'm just going to keep it very simple using the HTTP protocol. So I'll go ahead and yeah. So at this point of time, I do not have anything to configure in the security settings, because we are using the HTTP protocol. Next is health check. Now, as I said, the load balancer has basically needs to check the health of this EC2 instance. If it doesn't check the health of EC2 instance, how does it know whether this is working or not? And on what basis will it transfer the traffic to that EC2 instance? right? So the health check always needs to be conducted by the load balancer to see if the EC2 instance is really working fine or not, and if it works, then only the load will be transferred to the EC2 instance. So any user that who is trying to access, the load balancer is going to determine the load on the available EC2 instances, and based upon the load, automatically it is going to transfer the request. So here is a place where I'm going to configure the health settings of my load balancer. So on this basis, this is going to basically make a check on the EC2 instances. So the ping protocol is going to be HTTP, and ping port is going to be 80, and then I'm going to use healthy.html file. So basically I'm going to check for the healthy.html file on both the servers. So I'm going to check for on the server 1 at this specific place, that is usually the HTTP protocol with the port 80, right? So I'm going to say the name of the server 1 slash healthy.html. So if that is responding, which means first EC2 instance is working fine. Similarly, if I want to know whether the second EC2 instance is working fine or not, I'm going to check on the HTTP protocol. So it will be something like this. So the name of server 1 and then dot server, now name of the server 1 .com slash healthy.html, right? So it is going to check out for these specific files whether they are responding fine or not. So that is the one. Yeah, now the advanced detail section. So this is really important, so just pay attention on what basis I'm going to conduct the health check and how I'm going to decide whether it is healthy or whether it is unhealthy. So it is basically discussed in these advanced details. Now the first one is response timeout. So what is response timeout? Response timeout is basically time to wait when receiving a response from the health check. Now let's say if I go to flipkart.com, I'm waiting for a few seconds for this page to respond, right? It took around 3 to 4 seconds for the page to load across on my browser, right? So that is basically the response time. So how much time did it actually take in order to respond back, right? So I'm going to put it as 5 seconds in this case, and then interval. So if I'm not going to get the answer within the next 5 seconds, like if I was unable to open the flipkart.com in the first 5 seconds, I'll wait for the 30 seconds more. That is, I'm going to wait for an interval of 30 seconds and then I'm going to connect the next health check. And on what basis I'm going to say whether it is healthy or unhealthy? So if it doesn't respond for 2 consecutive times, I'm going to declare it as unhealthy. So what happens in this case? First time I'm going to go ahead and hit on flipkart.com. I'll wait for the 5 seconds. It doesn't respond. Then I'll wait for an interval of 30 seconds and then again go back and conduct a test and see whether it's going to respond back in 5 seconds or not. If it doesn't respond for the 2 times, then I'm going to say it as unhealthy, which means instance is not giving any specific results, which is not healthy, right? It might be down due to some other reason or maybe as such. Similarly, if I want to declare the EC2 instance to be healthy, how do I do it? So what I'm going to do it in this case is I'm going to keep the healthy threshold as 3, which means the first time I go and hit the flipkart.com, I get a response in the 5 seconds, and again I wait for the 30 seconds more. Again I'll hit a request to see if it is responding or not. Second time also it will respond. Again wait for the 30 seconds and check out if the third time it is responding or not. So if it responds all the 3 times, then I am going to declare my EC2 instance to be healthy. Right? So basically I'm conducting the test multiple times to verify whether it is really up and working or not. So that was about how we configure the health check. So first is where I am going to check for the health, right? So I'm specifically using the HTTP protocol, which is at port 80. I'm going to check for the healthy.html file. And how are we going to check out? We basically are configuring the parameters like response timeout, interval. So for now, I'll just keep interval very small one. I'll just say 15 seconds for now, so that our EC2 instances health check is passed much sooner. So any questions here on the configure health check part from any one of you? How about you, Rahul?
Hi, Pawan.
Yeah, ping protocols, we have it as HTTP, TCP, HTTPS, and SSL.
Yeah,
HTTPS, yeah,
Pawan.
yeah.
Yeah, while we configure instance, currently we create this configuration picture, or later we can be adding to the health check for
No, I didn't get your
existing
doubt.
instance.
Yeah, can you repeat your doubt again? Yes, we are going to conduct the health check on the existing instances itself. We are going to add the instances at a later level, but first we are going to configure the load balancer, and then we are going to create two different web servers like EC2 instance 1 and EC2 instance 2 here. It's not necessary that you need to have instances first and then you need to create load balancer. Nothing as such. You can create the load balancer first and then you can create the instances later, or you can create the instances first and then you can create the load balancer later as well. So there is no hard and fast rule that you need to create load balancer first, something as such. Right. So specifically, we are going to configure the health check here. So currently, we are going to check on HTTP protocol. So we have different protocols like HTTP and HTTPS. Now, if you remember from one of the encryption part where we learned in the S3, right? So there are two types of encryption. One is in transit and the second is at rest. So if you remember, while the data is in transit, how do I secure it? Specifically, it is either TLS or the SSL, right? So if I go to SSL, it does show me that it will be on the port 443, right? So if it is going to be SSL, it will be on the port 443, but if it is going to be on HTTP, then it is going to be port 80. Now, if you see, most of our websites which we use these days are basically HTTPS, which means I'll be able to easily go ahead and store my passwords or credit card information without any hassles, right? So that is where HTTPS comes into picture. The HTTPS is basically way of establishing a secure connection. But in order to conduct the health check, we can actually keep HTTP protocol itself, because anyway the load balancer is inside the Amazon AWS, and even the EC2 is inside the AWS itself. So the protocol which is going to help us connected between the load balancer and the EC2 can be port 80 itself. But if there are people outside the world and from there we are trying to connect to load balancer, then that should be basically configured to 443, which will actually help us to secure the connection. So we are going to learn about the SSL certificates in the upcoming sections as well. But for now, I'm using everything at a port 80 itself. So I'll just quickly go ahead and add the new EC2 instances. So we already have two EC2 instances which are running. I'll use the both of them for now. And if I scroll down the page, it does ask me enable cross-zone load balancing. Now, what does cross-zone load balancing mean? So if I have got my EC2 instances in different availability zones, and if I want to put across load balancer to balance the load between the availability zones, then I have to enable this. That is enable cross zone load balancing. If I do not enable this option, then my load balancer would not work in a better way. Now, as we all know, why are the availability zones there? So that even if one of them goes down, the other one is still available to serve the data. Now, when I want to create a highly available system or a highly available web server, what I would do, I would basically launch my web server in two different availability zones, and in front of it, I'll try to put a load balancer. So for that load balancer, this specific option should be enabled, that is enable cross zone load balancing, so that it will be able to balance the load across the multiple availability zones which are available in this specific region. And the next is enable connection draining. So the connection draining is basically the number of seconds to allow the existing traffic to continue flowing. So let's say if the traffic is being hitting onto my server continuously, so for how long it can hit onto my load balancer, and from load balancer to EC2 instance continuously, it can be up to 300 seconds. There can be billions of users who can come around and hit across without any problem. I'll quickly go ahead and add the tags. I'll just say name my classic LB. I'll click on review and create. So what did we do in this? Specifically, we had got 7 different steps, and the step number 1, I just gave the name of the load balancer, and then I told that it's going to be internet facing, and I'm going to forward the port number 80 from the load balancer to the port number 80 of the EC2 instance. That is my listener port configuration. And in the second step, I just went ahead and selected the security group. Remember, that was about web server security group we selected. In the third step, we didn't have anything as such to configure security settings, since we are actually working out on the port 80. In the fourth step, we actually went ahead to configure the health check. So I'm going to check the health of my instances on this specific path, that is healthy.html, and these are the parameters on the basis of which I'm going to check. So now my timeout interval will be 5 seconds. So the timeout will be 5 seconds, interval will be 15 seconds, unhealthy threshold is 2, healthy threshold is 3. And finally, in the step number 5, we were able to add a couple of EC2 instances which we have already running, and we ensured that the cross zone load balancing and the connection draining are enabled. And then let's quickly go ahead and launch the load balancer. Yeah, connection draining is basically allowing the traffic to flow continuously, right? Sometimes it does happen that if I have something like big billion day sale or a major sale that is coming up, I will have a continuous traffic that is actually flowing up to my servers. So how do we control them, or how long can I say the traffic can flow across to my servers without disturbing? Like load balancer is also a machine, right? It also needs some space to allow the traffic, because it always needs to keep a check on the EC2 instances, and thereby it will be able to traverse the traffic. But if I'm continuously sending the traffic to the load balancer, it might not have in between the time to check the health of the instances and traverse the traffic, right? So specifically, we are giving some grace period so that there is a chance for the load balancer to keep a check on the EC2 instances. At the same time, it is also pick up the traffic that is coming towards itself. Now, if you see the description here, there are 6 different properties boxes that we have. The first one is basically about the description. In the description, I can see that it is a classic load. The name is my classic load balancer, and the type is classic load balancer for now. The scheme is basically the internet facing, and we have just created it some time back. And this is the hosted zone, which comes with a unique ID by Amazon itself. And currently it says there are 2 instances, but none of them are working fine, because if you remember, we have not created this file at all. The healthy.html file is never created on these servers. We were just using those instances for testing out our EFS file system. We have not created any file with the name healthy.html. So we are going to go ahead and create it. I was still getting the background voice. Now is it better? Okay. Yeah, so we were just discussing about the descriptional properties of this EC2 series classic load balancer. So this load balancer, as we have just seen through, the name is My Classic LB. This is the hosted zone which comes with the unique ID generated by Amazon itself. And currently there are 2 EC2 instances, but none of them are in service because the health check is basically failing off. So let's go ahead and check, fix the health for them. And we have also ensured that all the availability zones are part of this load balancer. And we have also ensured to go ahead and pick up the cross zone load balancing here. So I'm going to go back to my EC2 instances here. So I'll first go ahead and clear the screen. I have to again. There we go. I'll just close this part. I'll similarly reopen the green server box as well. I'll just say duplicate session. So I'll just say EC2-user. So the first step I'm going to do is I'm going to convert both of them into web servers. So I'll have to first quickly go around and elevate my privileges. So I'm going to go ahead and first elevate my privileges. I'll just say sudo space su. Similarly here, sudo space su. And then I'm going to, first thing is I'm going to update all the security patches with the yum update -y. Same case I'll do here, yum update -y. So we are going to update all the security packages on both the machines. So there we go. We have been able to update the security patches. Now the next thing is we are going to install the Apache on this. So I'll say yum install httpd -y. Similarly in this case here. yum install httpd -y. So I'm being able to install the Apache on both of them. Now I'm going to go ahead and traverse to the directory. It is var www/html. So I'll just say cd/var/www/html. Similarly, I'll also go down here cd/var/www/html. Now inside this, I'm going to create one index.html file and one more healthy.html file, right? So index.html file is basically used as a home page of my application, and healthy.html file is basically used for this load balancer to keep a check on my EC2 instances health. So let's quickly go ahead and create it. I'll just say nano index.html, and then I'm going to put across this as HTML h1, and I'll say this is a web page from the, since this is black colored in the here, so I'll just go ahead and say black box server. I'll close the h1 tag and then the HTML tag. Let's check out what is there in here. Yeah, so it says this is a web page from the black box server. I'll quickly go ahead and save this. And similarly, I'll just create a healthy.html. So I'll just keep it very simple HTML page, which says this is healthy. Right, so we have created two files. Similarly, let's create it in the green server box as well. So I'm going to say nano index.html. I'll say HTML h1 /h1 and then /html. So let me add the content here. So I'll say this is a web page from the green server box, or I'll just say green box server. I'll control X, Y, and enter. That is saving it. And then I'm going to create one more file with the name healthy.html here. I'll just say so this is small HTML file which says it is healthy. So we were successfully able to create two different files in both of the servers. Now the last part that is remaining is to start the Apache service. So it's very simple. Just say service httpd and then say start. Okay. Okay, so it has now started Apache service. Similarly, I'm going to start it on the black server box as well. And then also ensure that Apache service is always up and running. So we are going to use this command check config httpd on. Now let's come back to our load balancer and let's look out at the instances portion, what it is saying. So if you see, one of them is still out of service, one of them is in service now, because one of them has been able to establish the healthy.html file connection. Second one is still maybe yet it has not progressed. So it is going to again check out the health. Let's wait for a little while for that also to come into service. Yeah. Now if you see, both of the EC2 instances are now passing the health. And if I come to description here, it will say the status. It says two of the two instances are in service. which means both the instances have passed the health check, and it shows it is in service. If the health check fails, it will say out of service. So now it is actually passing my health check. But before we can check out the load balancer, I'm first going to test out the instances here. So I'm going to select this IP address first and then open it up here. So it says this is a web page from the Greenbox server. Similarly, I'll just check what is the one for the IP address with each one, the server one. So it's going to say that this is a web page from the black box server. Now I'm going to balance the load across both of them. So I'll just come down to the load balancers. Now each load balancer will also have an endpoint. So this is the DNS name of my load balancer. I'll just copy it until here and just click on it. So you see it has first time directed me to the black server box. So if I keep refreshing this one, you will see that the request will be redirected to the next different server. So sometimes it will go to green box server, sometimes it is going to the black box server. Right? Again, it's going to green box server and then black box server. The green box server and the black box server. So you guys may want to give it a try. I'll just share the DNS name along with you on this chat box. So you guys may be able to check it out through your side as well. Right. So in the real time, what happens is basically I'll have the same configuration of servers. Just to show you the difference, I created wantedly the two different pages in both the servers. One with the green box, one with the black box. So in the real time, both of them will have the same configuration. Like the Flipkart homepage will remain the same across, right? So the Flipkart.com will be hosted as the same website in both the servers, and whenever I'm just going to click on Flipkart.com, I'll never be able to know which server I'm being redirected to, right? So in backend, it could be any server where it gets redirected to. And remember, we are actually being traversing the traffic with the help of load balancer, and the load balancer will never have any IP address. It will only have the DNS name, and the IP address behind this load balancer always keeps changing because it is talking to one of the EC2 instances, right? So Amazon is never going to reveal the IP address of the DNS name, and it's just going to give you the DNS name of the load balancer. It is never going to reveal you the IP address about it. So any questions or doubts here on the classic load balancer setup and how do we check out the health and other things? How about Divya and Rahul? Are you guys having any questions on this part of load balancer? Let's say I remove the healthy.html file from here. Yeah, let's get it down. Now, if you see in the green server box, I have only the index.html file. And you will see that the load balancer will fail the health check. You see, the EFS lab instance 2 is now currently out of service. So if you go back and hit the DNS name of the server that we were looking for, you can also refresh it out your system. You will see that all the requests are now being routed only to the black box server itself, because only one server is live at this moment of time. So what happens in real time is, if any of the server fails down and the load balancer is not able to proceed further, right? So it gives me a status saying that one of the instances is currently out of service. So what we can do is, we can go ahead and add new EC2 instance in the meantime to help the load balancer with the balancing of load. And how do we do it? Specifically, that is the next part of topic where we are going to learn about auto scaling. So it is automatically going to add a new EC2 instance and automatically going to remove the new EC2 instance whenever required, right? So whenever the load is increasing, I can add few more EC2 instances here. It's not like only 2, I can add few more here. So let's say I want to have 4 of them whenever the load is basically increasing off, right? So I'm going to use this auto scaling, which is going to basically help me overall situation. And whenever the load is going to decrease, it is going to also remove them off. And let's say if one of them is not working fine, it's going to remove it and is going to add a new EC2 instance as well here. So the auto scaling has got a real time capability of assessing the situation on how much load is there, on what basis it has to scale up, what basis it has to scale down, and it can also check whether the health, if the health of the instances is not fine, let's remove it from the load balancer and automatically add a new one. So all those are basically a part of auto scaling, which we are going to discuss in the next part of our class. So any questions or queries before we close the class for today? We have it on Monday now. Okay, so when we are trying to configure the health check, so what happens here? The first thing is I'm going to tell where the health check has to be conducted, right? So I'm basically checking for the file with the name healthy.html, right, on the port number 80. And then we have timeout interval. Timeout interval is basically in within how much time this page healthy.html is going to respond. Since we don't have much images or much videos to display on this healthy.html file, we have kept it very simple plain text. It should take only few seconds to reflect back, or few milliseconds we can say, right? So the timeout, we have kept it as 5 seconds, and the interval is basically how much time I have to wait before I can make a next health check. And then we have unhealthy threshold and healthy threshold. So what does unhealthy and healthy threshold mean here? So within how many, after how many consecutive checks will I be able to declare whether my EC2 instance is healthy or not? So in this case, I'm saying that unhealthy threshold is basically 2. So let me explain it here. So when I say it as 2, so what happens? First time I'm going to the flipkart.com. It has not responded, right? So I'm putting it as X. So I'll wait for an interval of 10 seconds. So it didn't respond in how many seconds? It didn't respond for the 5 seconds. That is what we have set across timeout. So we waited for 5 seconds, but still it didn't respond in 5 seconds. And now we have to wait for an interval of 10 seconds. So after interval of 10 seconds, again, I'm going to conduct one more test. And again, it doesn't respond, right? So it didn't respond 2 times consecutively, which means I'm going to declare it as unhealthy. Now, when we talk about the healthy, it has actually responded back, which means yes, it responded back positively. first time. Similarly, I'm going to go ahead and check out after 10 seconds again whether it is responding or not. It again responded back after 10 seconds. Again, I'm going to conduct a health check for the third time, and third time also it responded back. So if it has responded more than 3 times, then I'm going to say that the instance is basically healthy. So in our case, if you see here, so the first instance is consecutively passing the health checks and it is in service. And if it fails, it will be basically out of service. Now, basically, I'll show you how do we set up all these load balancers or the instances. Using the command line can also be done. We can also do it with the help of cloud formation, or we can also do it with the help of Terraform. There are 3 different types of scripting portions that we can take up. So we are going to cover up any one of them out of these 3. Okay then, so we'll depart for the day and we'll again meet back on the Monday morning to cover up the next part, that is about auto scaling. Thanks all, have a great weekend, and we'll meet back on Monday.